Hello and welcome to the Geometry B exam review. We are going to cover pages 16 to 18, which is questions 37 to 50. So let's get started with question 37. Okay, it says, now that Kelly knows the figure is a rectangle, if she can show that it is a rhombus, then it must be a square. Again, there are two ways to do this. So the first way to do this is to show that all four sides are the same length and therefore the figure is a rhombus. To show that all four sides are the same length, we can use the distance formula, which is distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and we're going to find the distance of all four sides, which are AB, BC, CD, and DA. Okay. Once I plug the points into the formula, into the distance formula, I'm left with the following. And when I simplify, each side comes out to be the square root of 25, which is 5 units. Okay. This shows that every side is the same measure and therefore the figure is a rhombus. Okay. Distance equals square root of 25, which is 5. The second way to show that the figure is a rhombus is to calculate their slopes and to show that the slopes of the diagonals and show that those are perpendicular. All right, so here are the diagonals. I've got AC and I have DB. Okay. Now there's two ways I can calculate the slope. I can use the slope formula, which is that the slope equals the change in y over the change in x, or I can count my rise over run. Okay. If I use the slope formula, well, AC is at 1, 4, and 2, -3, and DB is at -2, 0, and 5, 1. So putting that into the formula, I get -3 minus 4 over 2 minus 1, which is -7 over 1. And here I'm left with 1 minus 0, change in y over 5 minus -2. Right, two negatives make a positive. I'm left with 1 over 7. All right, these slopes are opposite reciprocals. I've got -7 over 1 and 1 over 7, so the diagonals are perpendicular. Okay, question 38. It says Kelly also remembers a property of parallelograms that the diagonals bisect each other. Show that this is true by determining the midpoint of each diagonal and showing that each midpoint has the same coordinates. So here is my midpoint formula, x2 plus x1 over 2 and y1 plus y2 over 2. And here are my diagonals. So I'm going to show that each of these diagonals has the same midpoint. So let's put this in the midpoint formula. Here's x1, y1, x2, y2, and label these x1, y1, x2, y2. All right, so I've got 2 plus 1 over 2, and I've got -3 plus 4 over 2. So that gives me 1.5 and 0.5. And over here I get, let's see, -2 plus 5 over 2 and 0 plus 1 over 2. And that also leaves me with 1.5 and 0.5. And so both of these diagonals have the same midpoint, which means that the diagonals are bisecting each other. Okay. Number 39. It says for items 39 and 40, determine the area and perimeter of each shaded region below, and each line represents 10 meters. Okay, so let's start actually with the perimeter. So to find the perimeter, you're going to calculate the distance around the figure. So I've got 90 units here, because remember each line is 10 meters. So I got 90 meters here. I got 10, 20, 30, 40, 50, 60, 70, 80 meters here. 50 here, 20, 40, and 60. Okay. When I add all these numbers up, I'm going to have 340 meters, and that's by adding 90 plus 80 plus 50 plus 20 plus 40 plus 60. Okay. Now, because this is an irregular shape, you don't have a formula for its area, but what we can do is we can break this up into two rectangles and then find the area of each.
Time, if you are set to start, you may begin. Thank you.
So I'm going to divide my rectangle up like this, right here, find the area of each, and then add those together. So the area over here, I have 20 by 50, that's 1,000 meters squared. And here I've got 10, 20, 30, 40, 50, 60 by 90, that's 5,400 meters squared. So when I add these up, I have 6,400 meters squared as my area. Okay? Alright, this shape is a trapezoid. So to find the perimeter, let's count the air distance around the figure. That's 100. Okay. This is 80 meters. This is 40 meters. Now to find the distance of this side over here, I'm going to have to use either the distance formula or I can use the Pythagorean theorem. So let's use the Pythagorean theorem. I have a triangle, a right triangle right here, okay, with sides of 60, and this is 80. I'm missing the hypotenuse, so my formula is going to be 60 squared plus 80 squared equals c squared. That's 3,600 plus 6,400 equals c squared. 10,000 equals c squared, and then c is 100. So the distance of this side over here is 100 meters. Okay. So now when I add all these sides up, I'm going to have 320 meters as my perimeter. Right? To find the area of a trapezoid, I can use the formula area equals base 1 plus base 2 divided by 2 times the height. So when I fill in the dimensions of the trapezoid, I have area equals base 1, the bottom is 100, plus base 2, the top is 40, divided by 2, and then my height is 80. Okay, and that simplified will give me 5,600 meters squared, and that is my area, 5,600 meters squared. Okay. Right. Number 41, it says for items 41 through 49, find the value of x in each of the figures below. So number 41, what we have is an angle inscribed in a circle, and the formula for an angle inscribed in a circle is that it is half the measure of the arc, right? So that means x is going to be half the measure of the intercepted arc, which is 50. That tells me that x is 25. Okay, number 42. Okay, again we have an inscribed angle. This time we have the measure of the angle and we're looking for the measure of the arc. Okay. The arc is going to be twice the measurement of the inscribed angle. So we have, let's see, 70 is going to be half of x, or you can say that 2 times, oh, okay, sorry, 2 times the measure of the inscribed angle, so 2 times 70 is 140. Okay, so we have x is 140. Number 43, okay, here we have a central angle Okay. And the rule with central angles is that central angles and their corresponding arcs are congruent. So here the arc is 160 degrees, so it tells me that the central angle is also 160 degrees. Okay, for number 44, we have two chords that are intersecting inside the circle. And whenever we have two chords or secants that intersect inside the circle, the degree measure of the vertical angles is equal to half the sum of the corresponding arcs of those angles. So the intercepted arcs are 28 and 60, and I'm going to add them and divide by 2, and that'll give me 44. Okay, so the vertical angles are 44 degrees. Okay, same type of problem here again, but this time they've given us the measure of the vertical angles and they're asking us to find the measure of one of the arcs. So I'm going to use the same formula, and that is that the angle is going to be half the sum of the intercepted arcs. Right? When I solve for x, I can cross multiply, so that gives me 170 equals 60 plus x. Right, subtract 60 on each side, and it tells me x is 110 degrees. Alright, in 46 they're telling us that line AB is a diameter and they want us to find the measure of angle x. Now this is an inscribed angle. Alright, and that is going to be half the measure of the intercepted arc. Right. So if I look at this like this, right, here I have an arc that is 180 degrees, because if AB is a diameter, it's cutting the circle in half, and half of a circle is 180 degrees. So this is 180 degrees, so now this is going to, the angle is going to be half of this arc, so half of 180, right? The angle is 90 degrees. Okay. Number 47, I have two secants that are intersecting outside of the circle. And the rule here is that the measure of an angle formed is half the difference of the measures of the intercepted arcs. So now I'm taking half the difference of the arcs. So x is going to equal half of the difference of these arcs. So x is half of 30, which is 15 degrees. Right, same type of problem again over here. So x is going to equal half of the difference of the intercepted arc, so 290 minus 70. And that gives me half of 220, which is 110 degrees. Okay. 49 this time, they're asking for the measure of one of the arcs. So 35 is going to equal half of the difference of x and 40. Okay. That gives me 35 equals, we can say, half of x minus 20. Well, we can add 20 to each side. Okay, 55 is half of x, so x is going to equal 110 degrees. Right. 50, it says quadrilateral ABCD is inscribed in the circle below. A is asking what is the measure of angle A right here plus angle C, equal to. All right, so if a quadrilateral is inscribed in a circle, the opposite angles are supplementary. So angle A plus angle C has to equal 180 degrees for it to be supplementary. All right. B says if AC is a diameter, so let's draw that in. If AC is a diameter, what is the measure of angle D or angle B? Angle D or angle B? Explain your reasoning. Okay. Because the angles are inscribed in a semicircle, the intercepting 180 degrees of arc, they are going to be 90 degrees. Okay, 90 degrees. Remember, the diameter is going to cut the circle in half, right? So here I have 180 degrees of arc, and same thing here, I've got 180 degrees of arc. Okay? So these inscribed angles are going to be half of those arcs, which are 90 degrees. Okay, and that is it. Thank you.